In this video, we're looking at how pressure varies with depth. So let me put it to you guys in this way. Say you're swimming over here. If you guys know swimming, I'm sure you have observed this. If you happen to dive deeper to say collect a coin and all of that, you get this ear pain. I mean, if you guys really dive deeper, you get this ear pain in your ears basically. That is because of variation of pressure as and when you dive deeper. That is, the pressure increases. So if I consider this as point A and this is point say B, so the pressure at point A will be more than pressure at point, will be less than pressure at point B. So basically what we are trying to tell is the force that you experience at point A will be lesser than that of point B. So let me give an example for you as an, so that you understand what I'm talking about. See, when it comes to ocean, so this is to do with pressure. And we are looking at depth. So the best place to look at is ocean. See, we understand 1 atmosphere pressure, right? That is, if I happen to stand on the surface of the earth, near your ground level per se, you experience some force on you. As of now, wherever you guys are sitting, you directly, indirectly are experiencing this force actually. But of course, the body is used to, and so you are not exactly feeling it, but there is a atmospheric pressure on you. You are bearing the weight of atmosphere. Okay, so that is your 1 atmosphere. If you just dive deeper, say 10 meters deep in ocean, that is, this value will change to 2 atmosphere. If you dive deep to 100 meters, it will change to some value, and that is as if you have 11 elephants sitting on you, And the deepest point that I kind of know of, that is 11 kilometers, that is your M trench. If we happen to go to this depth, it's almost as if you have 1,000 elephants, sitting on you. That's the pressure at that depth. So it's huge pressure actually. So you get to see this in submarine movies, So I think, I forgot the movie name. I thought I knew it. So if you have seen this submarine movies, guys, you get to see this, In submarine movies, sometimes they have to go deeper and deeper, and the nuts and bolts start getting loose and they come out and all of that. Have you seen those movies, submarine movies? That's because of pressure, right? So pressure, as when you go deeper, it increases. So mathematically, I want to show this to you guys. So I have told you that the pressure increases, but by how much is it mathematically? That's what we are trying to see in this video. So let me summarize the derivation with this discussion. Actually, it's not that hard. Say I'm considering a small cube or a cuboid space over here inside the pool. Say this is at a depth of y1 and say this is at a depth of y2. This section of water experience forces in all the direction that we know, right? So since any submerged object experiences force perpendicular to the surface. Now my question to you guys is, how much net force will it experience along the vertical direction? What is the net force that is acting on this small section of, or it can be any section actually, need not be small, this section of water? What are the forces acting on this section of water along the vertical direction is my question to you. So we know that the forces are always perpendicular to the surfaces. So there is a push down, there is a push up, and what else is there? There's one more force that is acting on it. What is it? Gravity. Even gravity is acting on it. So if this is F1, this is F2. Okay. So I need to figure out an expression for F2, relating it to Fg and F1. By doing so, I'll be able to show the pressure difference between a depth of Y2 in comparison to Y1. That's what we are trying to do. But does this make sense? Does this line of forces make sense? You have a force pushing down here. You have a force pushing up. Remember, we have studied this point. That is, water, any fluid, exerts pressure in all the direction, even upward direction. Remember that. So don't be confused that why is it upward? Because fluids exert equal amount of force in all the direction at a given point. Okay, so with that in mind, let's actually start the mathematical derivation. For your exams, you need to draw something like this and continue the derivation. Okay, guys. So first thing is, we will assume a liquid of density rho, and can consider this to be of depth d, this to be of height h, and what else? Okay, that's it. And we can consider this to be up, this positive direction, and we can start the derivation this way. So first we'll have some set of assumptions. We assume that rho is uniform throughout the liquid. So let's start with that assumption. Then also that liquid is incompressible. This is the assumption that we will make, is incompressible. You guys can't see that. Okay. Now, to continue the derivation, we need to consider a small section of, let us select a small, this is part, yeah, small, select a small or sample of the liquid. Contained within an imaginary, say a cylinder of few specific things about it that we need to know. So this has a cross section area of A. That is, if I happen to look at the cylinder, right? If I happen to look at the cylinder from the top, this area is A. Okay, yes. Then it has a extended from the depth of D, and it has a height of h. So depth of D plus h. What does that mean? So the cylinder starts from point or a height of D and goes up to D plus h. So basically this is h, right? So this is nothing but your D plus h. And this is D. Okay, so these are all the things that we need to make use of. Now, the pressure exerted or the force exerted on this cylinder would be, say, F1, then F2, and your mg that we kind of discussed already. or Fg. Let me call this as Fg. Much easier to discuss. So let's continue. The pressure exerted by the liquid so we need to write all of this, or the force exerted by the liquid or the pressure exerted by the liquid on the bottom. Since we are talking about pressure, actually, let me use the word pressure. At the bottom face of the sample is P. The pressure and the pressure on the top face is P naught. Okay. Therefore, force exerted at the top will be what? A times of P naught, area into pressure. Okay, because force is area times of pressure. Next, force exerted at the bottom. This would be A times of P. Then we have mass of the liquid in the cylinder would be rho into V, that is density into volume. Or we can write it as area into height. I'm not going to explain why volume is area into height. That you guys should be knowing. That's the mass, and therefore the weight of this liquid will be rho AH into G. That's nothing but your F of G basically, right? This force. Now, what should I do? How do we proceed? How do we interlink all of this? So till here, I've been writing few things that we can pretty much see from the diagram itself. Now, how will I interlink all of this? Right? Applying, yes, Newton's third law along the vertical. So we have the net force is equal to 0, right? Since the object is at rest, actually we can do this mass into acceleration. So net force along the vertical is PA minus P naught A minus M into G, or rho AHG. Rho AHG. This is equal to 0. 0 because the water or the fluid is at rest. That being the case, the RHS has to be 0. In all of this, A is common, so I can cancel A. And we have P is equal to P naught, bit of rearrangement, and rho Hg. And clearly we can see the pressure difference depends on what? Height. Can you see that? The pressure at a depth of H below a point in a liquid will be rho GH times more than at that particular height. So basically, if the pressure at point, what will I call this as? Y naught, if it's P naught, this will be P naught plus rho GH or rho GH times more than P naught. So if this is 10 Newton, this will be 10 plus rho GH. So it depends on the height. Okay, so that's all I wanted to show, that as and when you dive deeper, so basically the pressure difference is clearly proportional to height. So that is commonsensical if you guys have experienced it. If not, learn swimming, dive deep, you'll get to experience this. It's actually fun. Throwing a coin, getting the coin back. If coin is a bit difficult, you can throw a clean stone. You guys can do that. It's fun. Okay, so what is that we are looking at? We just looked at how pressure varies as and when we dive deeper, right? So first thing, I just gave an overview of what happens, how you can experience it. And in ocean, all these are just an approximate value and weird set of assumptions over here. But yeah, it's interesting set of facts, And we learned how to derive. It's a simple free body diagram scenario. So take up a section of water, look at all the forces acting along the vertical direction. We are assuming that the density and quite a few things, two things are same throughout the liquid. It's the same liquid, it's a standardized liquid. And we looked at the forces. We just used Newton's third law, substituted this set of values, and we automatically get the pressure in difference, or difference in pressure, sorry, is rho GH. H being your height. The pressure difference depends on the height. How deep are we? How deep we are, sorry. And I think I have one more thing to discuss. Be a diver. As divers, well known, water pressure increases with depth. Be a skydiver. Likewise, atmospheric pressure decreases with increasing altitude. For this reason, aircraft flying at a higher altitude must have pressurized cabin. If you guys if you're not heard of it, pressurized cabin is to do with your flights, as in when you go elevate up, basically, as in when you fly up the atmosphere, your chambers, the cabin, the pressure actually changes. So the pressure is lesser, actually outside it's lesser, but the structure and the engineering is so that the pressure remains the same inside the cabin. That's why whenever there is in movies, or actually in movies only, in animation also, if there is a small opening by chance in any plane, air gushes out. Nothing comes in, people fly out. If you have seen the movies, people get sucked out because of this, actually. So experience all of this. Be a diver, be a skydiver. Experience all of this in your life. You have a lot of things to look forward. Enjoy your life. Learn, observe. As a science person, I would always ask you guys to observe things around. Experience it related to whatever you're learning. So that's why I have this slide. Okay. So yeah, pause, have a look.